happened, so that's a good news. Just wait 5 more seconds, please.
So shall I share a few questions to start off with? We don't have.
Yes, please. So the discussion panel is now officially open. Edze, please, you are the host. So
Yeah, so Hannah is actually the moderator, so go ahead. No? So I'm a panelist and a moderator. Okay.
I think it's fine to reflect. There were many good questions, and there were some, I think, questions which are bigger and questions which are smaller, and maybe we can start with the bigger questions and bigger discussion points.
Right. So it's great to have so many people here in the panel, and there is, for those who are participating in this summer school, there is the Mattermost channel called R Spatial, where you are encouraged to submit your questions that we will then that we can then discuss. I have a couple of questions prepared that we can kick off with. Let me just share them. I'll share my screen. Here it is, and they're not better than any other questions, but they're just a suggestion. This should go away. So as a first, kickoff question is the diversity of R packages. For instance, for raster data, like we have now, raster, Terra, stars, SP, and potentially a number of other ones, and sort of native R structures. And also for vector data like SF, SP, and Terra, is that good or is it rather confusing?
Or both?
Anyone?
Can I say something?
Yeah,
I
answer on the question. Yes.
Yes, I actually have two types of experience. One experience where the packages which kind of overlap and are made by same people, and they just decide to drop it, and I don't like SP, now it's SF. I don't have a problem as long as there's still bridges. So if it's like relatively easy to pass in one line seamlessly, if it's relatively easy to pass the data or even combine, not a problem. But I have some experience with R packages, and at the moment I'm really struggling with migrating from MLR to MLR3, where literally the group, they change the names, they change the classes they use, they change the logic, how the things are organized, and it's really, I'm shifting away. I feel like I'm shifting away. So
let me then add a little bit of background information on that one. You mentioned SF and SP. So SP is good really because we have ArcGeos and ArcGDAL, right? Because these packages do the heavy lifting, reading and writing of data and doing geometrical operations. So that makes things a GIS, I think, right? Now we have the following situations: that these packages are being maintained, have been written over a course of 20 years, so have sort of collected an enormous amount of experience and versioning. So if you read the code, then you think, oh, oops. And they are now being maintained by Roger Bivens, who is 70 and just retired, right? And he's clear that he's not going to continue that. So he says 1st of January 2024 is the deadline for any dependencies on ArcGeos and ArcGDAL. It will just stop, right? We will think of a contingency plan, right? But unless somebody says, oh, hey, I want to do this for the next 10 years, yes, that is going to happen, Tom. So it is, I think it's, you can call this progress or whatever, decay or whatever, but it is development, and I think it's a property of an ecosystem that people, retire, and that you need to think about continuation of things.
Yeah, no, I absolutely support evolution. I mean, that's not an issue, and I know that sometimes, I think like with the SpotStat, we saw that it's a great package and people use it, but for example, it just became too big, and so all my code I had with SpotStat doesn't work anymore. So I had to change the, but I only had to change the addresses. They kept the function names, so it's still a relatively smooth transition.
I think there are really two questions here. I mean, Etzer addressed a really interesting point, which is even a third issue. Like, you know, but there's two questions. One is there's this progress. I think it's very clear SF is superior to SP, or at least it solves some problems. And I think the same. You know, in my view, Terra does the same for raster. And so it's good to have progress, but progress costs, you know, that's painful. Another question is, you know, you could say raster SP and Terra stars, where you can say, well, now there's parallel packages that do similar things, you know, which is a separate question. I don't necessarily want to say if that's good or bad, but it's probably both. But maybe somebody else wants to speak to that. But I think that question of progress is yeah, well, you know, I mean, it's you at some point you just have to move on.
Yeah, and I think Robert is totally right that there are pros and cons on having two parallel softwares doing similar stuff. Like in this case, we are discussing stars and Terra. But I think also Tom made a great point that in those cases, we need bridges. We need to have functions in probably both packages that users can jump easily from stars representation to Terra representation of raster data, and from SF to Terra representation of vector, and then the other way around. I think that's crucial for users, because we need to interest people in programming. We need to interest people in open science, open source, and that's, in my opinion, that's why we need to lower the entrance, and having those bridge functions, they do that.
Yeah, I think I wanted to continue on that. So there's I see two dimensions. So first of all, the diversity that we currently have, and the continuation over time. So the second question. I think the diversity in the horizontal dimension, so the current diversity, is really good. I mean, for instance, in the visualization things, yeah, so when I started with TMap, ggplot was not good at all in geovisualization. Now it is. But TMap gets better also. And it's just improving. And same with MapView. And we are just building on top of each other. And I guess the same thing is the case for stars and Terra, etc. The thing I'm more worried about, the continuation, so reproducibility over time. And maybe we need some kind of versioning system. Let's say, okay, this only works with version and some snapshots of the CRAN library. But
Answer?
Yeah, go ahead, Gilberto.
So I'm speaking from experience of a developer who has been working with all these packages, and I mean all, for the last 5 years. And it took us considerable work to keep compatible, and RGDAO as well. So you add RGDAO to that. In my package I use, so it's the first one I dropped was SP, because I found that SF does everything at least I need, and it's very comprehensive. It's getting better by the day. And then raster and Terra, what happens is Terra is not a full replacement for raster yet. I mean, for example, if you want to work with MapView, MapView only supports raster, but not Terra, at least as 1 month ago. So it's a problem. Certain things cannot be done in Terra. I mean, Terra is now much more stable. It was very unstable, so to the extent that we had to have you start sits by telling which API you're going to use if you want to use raster and Terra, because in certain points Terra did not work. But of course, things are improving. Now, what is a little bit more complicated is I personally, and I think this is between people who share the same spirit, I don't find the idea of spatial vectors in Terra very appealing, because I like the SF style, because you have clearly a standard to which you define with. So if you fully support the OGC standard and fully support the operations, that makes my code much more stable in the long run. So and the other point is that I'm struggling with GDAO. So what I like about Terra is to remove the dependencies on GDAO. which helps a lot. And I would encourage us to remove completely the RGDAL dependency if at all possible. It's still the case, there are Terra and stars, and I think, well, I use both. There's things that stars does that Terra doesn't do, there are things that Terra does that stars doesn't do. I really, of course, appreciate the effort, so I don't think there's a point of criticizing. It's just that for a developer who needs to do things with spatial data, you have to learn every one of those packages. You have to understand each one of them. And therefore, I mean, I'm an R user. I've been using R from, I mean, as long as some people have 20 years at most, at least. So it's not so much work, but for young developers, this plethora of packages, which does something and the other does something else, really is not really good.
So who wants to follow up on that?
Yeah, well, it's hard to ignore. I mean, there are different initiatives and different things, so I'm not sure how to solve that problem.
Mm-hmm.
You know, is it a problem? Again, it makes the question. I mean, I understand that confusion is a problem, but it's also, you know, I thought that Etzer's example of mapping was a nice one. You know, I also saw that, you know, in Martijn, your presentation, you were, you know, showing new things in TMap that, you know, Terra already does, and so like, and, you know, in some ways I thought that's interesting because, you know, it's. There's collaboration, but there's also competition in a sense, or like say, oh, if this package can do this, maybe I should be able to do this. This package should be able to do it as well. And so in sort of an ideal world without any, you know, where without any loss of effort and you know, we would work differently. But I don't think examples exist, or very good examples where there is no variability. So I think in the end it's the strength that to have the diversity, but there's just a cost to it. The question is more indeed, I think, what Jakob referred to is like, well, how can we best work then with the diversity? You know, how can we emphasize the collaborative aspect? How can we emphasize understanding of what niches? I think you know, a particular packages work on. I think particularly initially, maybe less so now, but initially when I started working on raster, I had a very different niche I think than what Etzer and Roger were thinking about in terms of applications. Maybe that's less the case now, but I think it's yeah, the question is how to harness our strength, how to use our diversity rather than to be too worried about it. In the end, also, you know, users will vote with their feet if nobody's going to, or with keyboards, so that, you know, if in the end nobody's going to go from raster to Terra at some you know, at some point it's going to give up. And so we'll see. And so if the problems that Gilberto has referred to, which I think are mainly sort of, yeah, early release issues that for, you know, one of the things with our packages, the way I look at it is like, yeah, I have to release early so I get the feedback. But I you know, assuming that those issues will go away, or have gone away, I think it's a strength much more than a weakness, or I think we should try to work on that strength rather than agonize over the weakness.
Yeah, Gilberto, you had a comment?
Well, my point is, I think there should be competition, but I think we have to at least agree on a common core of packages which we would like to work together.
Mm-hmm.
So, I mean, one small example is the Terra extract. You cannot extract, so you want to extract some points from a raster, and it would be nice for everybody if you could, for example, in Terra extract, get an SF object. Now you either have an SP object or so I have to pick up a shapefile, take the SF, do a lot of wrangling with the data to pass the matrix to Terra currently. That's how it works. Now, if we at least say Terra should talk to SF, as a minimum, they should talk to each other. Because SF
I believe it does, but that's another.
extract to the last of the version of Terra. I wrote that code. Extract, you cannot pass an SF object. Look at your documentation.
Yeah, no, I mean, but you can say, I mean, the question is how much should it talk to each other? I mean, so you can do vect, because you talk about making matrix, but you can just basically vect SF object and then it works.
Right, but that's not in the documentation.
Well, elsewhere is that, I guess elsewhere is that you can make a spat vector. You know, it's very hard to find, you know. But
my point, Robert, is not hacks that you can do. My point is that it would be good to signal to others who are outside of this debate that as a minimum, certain packages talk to each other in an effective way.
yeah. Well, again, I'll give a quick response because I feel sort of, you know, that you know, it's sort of addressed to me as a Terra developer. But I mean, I agree with you. For me, and it's you know, the package is still early, and I've been cautious of not sort of doing a kind of a bloat, because of course there is a spat vector object. I could have, for everything a spat vector does, I could also have a version that explicitly takes an SF object, but so now I would have to write, you know, another 50 little variation on that function, on the same function. So I haven't done that. So it's to me, it's not obvious that it should work the way you think. I think to me the obvious thing for people to understand is that, yeah, this takes 4 letters and 2 parentheses to get to coerce the object. But fair enough. I'll take your comment. You're not the first one to bring it up, so I may to look at that more.
I think from a developer perspective, what developers try to do is minimize dependencies, right? Because we have packages that many people depend on, so they want to have, you know, not a sort of massive dependency explosion. And sort of SF and Terra are both sort of relatively big undertakings, right? So they are, you know, larger packages with functionality and also with system requirements. And so there is a little bit of, you know, you need to be a little bit cautious about sort of dependencies you build in. That is, so you leave that to the user then, right? So okay, you get, you know, you want to have 2 systems, then you need to sort of juggle with your classes and do the transformations at a certain time. But I understand your point.
Would it help if there was like a 1 week hackathon where you and Robert and you know, whoever is building the basic packages will sit together and at IFGI or something and you know, just go day by day, go through issues and try to see how to.
You know, Tom, Robert and I go day by day through issues. Don't worry. Don't worry. Yes.
Well, and you know, I mean, one to speak one specific point. So, you know, Jacob has been one of the greatest contributors to Terra because of he is writing thing in GitHub. So there's one pending thing where, you know, for example, Terra cannot yet read a stars raster. So I just haven't done that yet, but he put it there, and it will be done, you know. And so I think, yeah, it's.
I also done similar pull requests for stars, just to ping Edzer here.
Yes, very good. And we also have sort of had excellent contributions from Krzysztof Diba, a guy from Poland, who wrote all these, a long list of sort of standard raster operations and did them in Terra, in raster, in stars, and in raster.io, which is Python. And looked at the timings of things and said, hey, you know, why is this 100 times faster than that one, right? Can you look at that? Is that, and then, you know, these are the things where we think, hey, oh, this works within a millisecond, but then somebody else does it 100 times faster. So if you do it for a massive data set, that counts, right? So those things are really useful. That is something that we sort of still need to sort of look at what to do with that, with all that work, how to publish that or share that or make that sort of more widely seen. It is extremely useful for developers and users to know these things.
If I may just interrupt you, we are now discussing as panelists, but we have also lots of people connected, almost 80 people. So if there's any question by attendees, please put it in a chat, or you can raise your hand, I think, and we can give you a microphone so you can also talk. Please continue, Edze.
Yeah, so maybe we want to go to the second question. There is also a question on the Mattermost that I can read aloud. The user conference often has many people showcasing new packages. Why do you think maintaining already available packages is not attractive to volunteers or not have takers? My comment was specific to RGeos and RGDAL, and I just invite you to look at the source code of those packages, and then you will understand. Yeah, that this is absolutely not about taking over maintenance of packages in general, but just these two use cases. And Roger actually agrees that sort of energy of developers should go into new things and not sort of in keeping these things afloat. So it's still, I mean, if anyone sort of is willing to do that, then that would solve a problem. It is just not so likely that will happen. Just go to the package and look at the source code. So this is I didn't want to give a general impression that the packages that get orphaned, that there are no. I have also picked up packages that were orphaned and that I am already maintaining for 8 years or something like that, which is really a very small job, quite often, and doable. Another question that Robert came up with is that of reproducibility. That is how can we preserve our workflows and maybe even runtimes, the software that they require, such that they are easily reproducible or at least practically reproducible some years from now, where n is 5, 10, 20, or 50. Our National Science Foundation, the DFG, has a requirement that we still have everything and can still do everything for a period of 10 years. It's a requirement to get funding. They never come and check. Yeah, but this is basically a rule for getting funded. So the obvious question is versioning. So if you look at packages now and how they were 10 years ago, there are extreme differences. The only thing that's similar is a couple of functions in the package name. And then there is the things like, Geos, GDAL, or that sort of upstream software that we constantly use in these packages that also strongly develops. So how do we do this? We have been running a project and trying to implement something and create an infrastructure for that was not very much picked up by journals, with which the target audience, where we suggested to do this with Docker containers. Right? Is that enough? Or do you really have to, because the container is a script that then depends still on that script running at some point, or could you actually, or you conserve the compiled container, so to speak? Yes, both the Docker file and the compiled container. Yeah, okay, all right. Yeah, so the hope is that if we do that we can run that, and that basically a virtual machine, sort of a time machine that runs the same stuff in 10 years from now, if that still, is alive and affordable, right? I got an email from Docker this week that they stopped their free plans for massive usage and so on. I mean, Docker is also a company. So this is we have, so Robert and I and many people here have sort of think, one important reason we do this is open science, is reproducibility, and does it work like that? Is it enough to, to save your R script and your CSV data file? Is that enough?
So as someone who's mostly just a user of these tools and doesn't really do much development of them, I definitely wish I knew more about containers, because it's not just about other people being able to use my work. It's also about me being able to use my own work that I did 5 years ago, which I usually cannot reliably do. So it is something that I wish I knew more about. I mean, I know that there's some interfaces between R and Docker, and you can pull in all the spatial packages or some of the spatial packages that way, which seems like the right direction to be going in. but it would be nice if it was more formalized for someone like me, who's, as I said, not so much a developer, although I understand how these things work and I'm comfortable with, writing my own scripts and things, but don't know all the bells and whistles of these things.
Yeah. In your case, you're working with RInla, which is also a massive project, really, in terms of amount of software that is involved.
Yeah, someone in the Zoom put in how exactly big it is during my talks. They said it's something like 160 megabytes. It's big.
A problem is that it downloads all Windows and Mac and Linux and everything at once, and then only uses one of them. But nevertheless, it's a very large project. Yeah, and if you keep a binary, you also need something that runs that binary, right? So, and the Docker container could do that, I think. I mean, it's the closest that we're now that, I think.
We had on one summer school, we had Daniel Nust, and he was teaching the reproducible research using Docker. So it was very useful. And the videos, I think we still have a video. But I agree, it's also changing rapidly. So there's a lot of new things, and maybe next summer school we should add it then. I think that's a good idea to add to next summer school more on reproducible research. I think there's a consensus on here among the panelists. This pops up as something important.
Mm-hmm. And the only thing I would add to that is that while I think this topic is dear to my heart, I'm really interested in it. At the same time, I see it as somewhat esoteric, the Docker side of it, the long term, because I think that for most people that I work, myself included, even irrespective of that, it's actually really hard to say, okay, here's my reproducible research. Here's my script, you go run it. That remains a challenge, often, particularly with spatial data. So that seems to me the bigger fish to catch still. Yeah. To really think about how do you do that? How in some ways the problem with it is really simple. You just write good scripts, but in practice people don't seem to be able to do it. So there's also something to further work on there. If you have that, then of course, obviously, or irrespectively, the other part is then it'd be nice if you can also reproduce it 10 years from now.
Yeah, there is a nice development also with Zenodo. There's a package for Zenodo, an API, so you can put like a code on some repository, like a Docker repository, and then you can put also data with the DOI. Because data often, you can have the same file name, but it's been manipulated. Like as you said, Robert Hymas, don't touch the data with your hands. So I think that's a nice development too. And Zenodo is a 50 gigabyte per bucket. It's a hosting paid by European citizen by a European project. And you can program from R. I tried it and it does work. So if you have a lot of files, you don't have to go to their interface and upload. But the upload speed was a problem. I had issues with the upload speed. That would be like a few megabyte.
Gilberto?
Well, my particular take on this is that I'm particularly more interested in reusable research than a reproducible research. I found that, of course, reproducible research is a goal in itself, but from the constituency I'm working with is how to reuse ideas, good ideas in different contexts. In terms of course, any area. Of course, you want to reproduce your work later, or someone wants to reproduce, but more interesting is how I benefit from your work. And in this case, I think the key here is to have stable packages. Even if they change a little bit, you have the more stability you have, the easier the reproducibility becomes. I think, Rasta did this for a long time. SF is now doing this, and hopefully Terra would do it. And so even if the user has to do some adaptations and recompile and just some change a little bit and do some tweaks, as long as the core logic of the script is preserved and it can be reused by people, this is fun. This is all very important, and essentially this is the aim of the R community in the end. You should not put too much emphasis in reproducibility compared to reusability.
Thank you.
Yeah, I agree. It's a shorter goal. This whole 10-year thing is of course annoying, but it's basically it's a moral obligation as a scientist receiving funding with an organization that requires that, right? So NSF has similar things in place, I assume. Although the question is whether they sort of check it. Yeah, so I agree with that point entirely. Another question I had, we got a question on the Q&A session. Please, could you tell me why is R more preferable than Python? I don't think there is really a majority here that thinks that R is preferable over Python. They're both good, data science environments and have their strengths and weaknesses in different aspects. And Python is a general purpose programming language, which is very convenient in many cases. We have to jump to C++ if we want to make things blazing fast and so on. And on the other hand, if you are about statistics and spatial statistics, then nothing beats R because of because of the history and the community there. So there are different strengths and weaknesses of both, I think. If anyone wants to add to that.
Maybe a question for everyone: how many people use Python from R to reticulate? Or
well, occasionally, yes.
Yes.
Exactly.
Okay. That's good to know. And do you see it as a cumbersome, or you feel like it's smooth?
Oh, yeah, there's the package hell in Python, but otherwise, no.
Okay.
Well, if I use Python, I tend to use it just by itself. I have a slide that I didn't use today that says Python is for programmers and R is for researchers, which is not fair, of course, and Etzer said much more balanced. But I do have the sense that if you're more a developer of software for others, in the sense of or some software that runs a lot on the back end or so somewhere, and then Python R clearly is not what you're doing. But if you're a researcher with a more, with this, in a particular research project, with R, also the sense you have the data in your hands. You sniff it, you look at it, you open it. It's the interactivity of R is just really what I think why it's much more popular in sort of academic researchers, and people with a more programming view tend to prefer Python because it's more that type of environment. But then again, Esther said as well, you can do either thing or most things in most environments.
Maybe a nice follow-up question. How about Julia? Because I think it's like best of both worlds. However, it doesn't have so many libraries yet. It's not so mature yet.
Well, there's an active Julia community.
I think it's the future. I mean, I think in 20 years, some people here will be retired, and maybe we should switch.
10 years.
10 years already.
Oh, you're lucky, Tom.
No, I was talking about you guys.
Yeah.
No, seriously. I mean, I did some things in Python, but I'm really a little bit hesitant to get to know Python so much better, just because, like Etzer said, like this library hell and things that doesn't work so well as with R. And I think, why shouldn't I spend my time in Julia if I want to learn a new language?
So does Julia have a proper NA?
I don't know yet. No.
That's the problem with
Somebody,
Python. Right? It does have
Julia?
all the built-in types, but it doesn't have NAs.
Yeah, let me know. So is anyone from the audience experienced in Julia?
Please use
Monica?
the chat.
Somebody says, I'm switching from Python to Julia. It's mind-blowing. Maybe we can invite Monica to talk. Let me just see. Monica, would you like to say something? We can put you to talk, please. If you just turn on your microphone.
Yes, hello.
Hello, we hear you.
Thank you for inviting me. So my experience with Julia is not that long, and however, I've been just rewriting my scripts, which I have in Python, which do a lot of processing on rasters, and then modeling some vegetation indices. So the model, I rewritten that script from Python to Julia, and it's just like almost 10 times quicker. So yeah, this is
You mean the
crazy.
processing? The processing was
Yeah, the
quicker,
processing
not the coding.
times is
Not
like
the-
almost 10 times.
Okay. And the
However,
coding?
the Julia is still far behind Python, the number of packages in Python and so on. Right now, Julia, there's not as much. Really small number, and most of them are under development, and there's not as much things as you can do probably in Python. But I believe with time, more people may be just switching, and it has a future really. But yeah, this is just my limited experience, but just the timing you're getting, the speed is just something really worth to spend time with Julia and see if you can switch your job from Python to this process.
Okay, thank you, Monica. Thank you.
All right, thank you.
So as a follow-up question, not entirely unrelated, I could sort of had this one on my screen, which is the third. Should we as sort of our community, our users, our developers, seek more interaction with the Python spatial community or Python community in general? And if so, how? And who is willing and likely to do this? So I interact with some people on Twitter, for instance, asking how far they are to do spherical geometry in case they work with ellipsoidal coordinates. Then they follow a couple of people there, Andrea Ballatore and Flores. Well, no, what is his name? The GeoPandas developers and so.
It will be very interesting to have also hackathons to give assignments, but like not thinking about software, but just assignment, and then have in parallel, people trying to solve it in R and in Python, and then see what are the differences and what worked, what didn't work. So that would be interesting.
So the whole sort of processing of satellite imagery is dominantly a Python game at the moment, right? Open Data Cube, X-Array, the whole stuff. Sort of everyone is doing Vito, EODC, all these groups that do big data processing at the moment with lots of satellite imagery. They're all doing Python. Yeah, go ahead, Gilberto. Except for Impy.
I beg to disagree.
Oh,
I beg strongly to disagree.
well, this is Europe.
I process high 200 million hectares in one day, a full Landsat archive. I beg to disagree, and I do it in R. So I'm sorry.
No, good. No, I'm happy to hear that. Yeah, of course.
And I have no plans for switching to Python anytime soon. And I don't think X-Array plus DES gives you a solution which is good. I think there's a lot of myths about it, but we should not say OGC is fantastic, ODC it's not. We just basically, the X-Array solves the problem in memory, but then you have DESC, and it's much better if you do everything behind the hood and give efficient processing. And that can be done with R, and programmers should be much happier. So I have a long dispute with the ODC guys, and I keep telling, do what I do, and no one can reproduce what we do in R.
Cool.
I have 3 employees and they're Python programmers, and I tried to get them into R, and they just laughed at me. Even I made some codes processing table data and merging and cleaning up, and they took the code and they translate to Python. They didn't want to touch R.
I think the point here is the following. For going a little bit further on the edge of discussion, if you want to do efficient, large-scale raster data processing with R, you have to write your, let's say, your processing machine. That's my lesson. We've tried to use parallel, we've tried to use futures, nothing works. So inside SITS, we had to do our processing that processes large data sets using multiple CPUs. So I think this is a package that does this large-scale raster processing in multiple CPUs is missing in R. And that's the trick that I had to do, or my team had to do, and then now we're very happy with the result.
Okay, but Robert, like for example, I mean, he makes now in Terra, most of code is in C++, if I understand. So your most of your code is actually C++. R is just a shell to connect functions. Is that correct, Robert? We don't hear you. Microphone.
Let me, before I answer that, first a general reflection. I think it's just not that interesting to ask the question, you know, which language is better. I think what's important, you know, assuming that, you know, many of you listening to this are, you know, relatively young in your career, new in your career, is that you learn the general principles of programming. You're both about reproducibility, but also what's a for loop, you know, what's if then else, what's a function. Because the nice thing about computer programming languages is they're all the same essentially. You know, once you get right in one, it's relatively easy to go to the next one. So just keep that open mind. And if you're really good at R, have a look at Python, have a look at Julia, do some C++. It's really interesting. Because you know, I understand why Tom's programmers, if you're already good in Python, it's difficult to go to the next language. But at the same time, you know, so that costs time. But prepare yourself a bit for that. Now, on the question that Tom asked me about, yeah, so Terra is C++. It doesn't do automatic multi-core or anything like that yet. I mean, there's some support for it, and the reason is that, you know, that with the C++ version 17, a lot of that is built in, and so my hope is that over the next year or two, I'm going to start to build that in. I'd be very interested to talk with Gilberto to sort of see if to what extent that can be done, although or that could solve some of the things he's doing. At the same time, I think it also in that discussion about Python versus R, if you're at the edge of sort of, you know, data analysis, most of us, I feel, are dealing with often with complex data, but not necessarily with huge amounts of data. Some are. I mean, Gilberto clearly is. It's very often the case, and there you may want to go to. You may want to go to Python or R. It doesn't really matter, but wherever you go, you'll have to think very carefully about your about optimization of your code. But I say this because, you know, Donald Knuth said, of course, you know, optimization, premature optimization is core of all evil. And I think that many people think about, you know, HPC or multi-core computing when they don't really need it. But yeah, once you need it, I think Terra will provide eventually more automatic support for it. But even so, you know, for really large problems, you really have to be a bit more of a software engineer, and any general solution may not be as good as you might be able to get it otherwise.
That's a very nice point, Robert. I completely agree. Language should be secondary. Most important is the creative, you know, the creative intelligence. But my Python programmers, no, they don't want to touch R. They just said, no, this is for little children. And it's true. And then if they're very good in Python, you know, they can everything. Even I tell them, look, there's a package made. It does everything. Let me look. Oh, no, we make that. And they just remake stuff in Python. And it is, they show me it's for serious projects. It's because there's, you know, when you process especially large images, satellite images, and then you have maybe 3 times, you can have one process which is 3 times faster in Python, and that's it. They don't want to do it in R.
So there was a question on the Q&A. I've heard a couple from Andy Lyons. I've heard a couple of events that the leading and latest deep learning libraries are mostly in Python. Is that correct? So I think so that sort of if we think of TensorFlow as one of the leading deep learning environments, then that is mostly interfaced through Python, and there are a number of R packages. Actually, the package Reticulate, the modern R Python interface was exactly written with the purpose of making it easy to do TensorFlow from TensorFlow and Keras and so on from R, so that you get kind of a seamless interface and usage experience. So that is true, but it doesn't mean so much. It's just language. Gilberto, you had a comment on that?
Well, my comment is I use Keras and TensorFlow and Reticulate in R, and in the end, everything is C++. So there's no real advantage of Python over R. It's just that you have everything in TensorFlow, you have it in R. So I mean, this is no reason to choose Python over R. I mean, there are other reasons, but I don't think this is a good reason. Well,
the reason why people use R for doing TensorFlow and Keras and so on is that you have the graphics, right? That you can explore the results graphically directly, irrespective which platform you are on and so on, and get proper graphics and working and so on. Yeah. There is a question on the Mattermost from Floris van der Hagen. Given good bridges from R to external raster geoprocessing software such as GRASS, I can live with not having the same performance offered by R packages. Then is it necessary trying to achieve a similar performance in R and invest in that? Yeah, that's a good point. I think this is also kind of the reason why we look at bridges and build them and try to support them and make people use them and find people to take them over when people retire. RGrass 7, looking at you.
I find those bridges often very clumsy and limiting. So I try to avoid them where I can. Just use them where there's just no better solution.
Right. Well, Google Earth Engine is a big elephant in the room here. So, you can use RGE, or you can, what's the alternative, right? If you want to do whatever, a global coverage of Sentinel-2 composite over the last year and something like that, go ahead.
Is there one thing I noticed with R, it's getting really stronger. It's this R Shiny. So building up like apps, so for people to do interactive exploration of data and kind of, you can, like we used to maybe 10 years ago, we were happy to make these notebooks, but now with the R Shiny, you make kind of a notebook, but it's visual and it really becomes like a GUI also for non-experts, and allows people to do that interaction. And I think we don't have that in the summer school, but maybe next summer school we should consider having a session on like R Shiny for geospatial data and geospatial applications. I think Martijn is writing his book also. He has a R Shiny section I saw. And
Yeah. Yes, there will be a section. So it's possible to use TMap in Shiny. But I really have to work on the computational speed because when you interact, every millisecond counts. So
yeah,
that was
absolutely.
rather high level, but the challenge I will take on.
Cool.
I can, maybe next year I can tell you something about it.
Right, there is a question from Nicolas Roeland on the Mattermost. He says there is an initiative to approach the OSGeo community. Can you speak about that? And how is the process? Right, this was picked up on the discussion issue on GitHub r-spatial. And we applied for becoming OSGeo community project with RSpatial, yes, with a number of RSpatial packages, which is then the software. And so we applied for that, and the process is basically that the reaction from OSGeo was very positive. So they thought it was not like an issue to do that. And we are organizing a panel session at the FOSS4G with a number of people who have committed to speak there. The process is that we have to basically make a community website on the OSGeo thing, and I've started that, and it gave me lots of errors from WordPress, and then I stopped it. So I think this is, with this work in progress that will happen, and the idea is there that we get some more interaction with that community, because we essentially sort of, a lot of the things that we do is built on the libraries Proj, GDAL, and GEOS. So that is not kind of a a small thing, and we need a lot of interaction back and forth to get things going and keep things going. So a large section of actually the OSGeo's users are our users, and they don't even know that they're doing that, right? So they know these packages are 100 megabytes, but they have no clue what's inside it, right? And so that's why SF gives a startup message like, I have these versions for GEOS, for GEOS and GDAL, and Proj actually linked to me, and so you can see that. And so we're working on collaboration, and people from the R community need to be on these mailing lists to see what's going on, and to check whether and communicate with the cron maintainers and people like Jeroen Ooms, to see whether they can update versions, what new developments break their systems constantly, and so on, and get sort of keep the thing running. And that's a big effort. So it's not like GDAL is not like one library. It's a library of libraries that sort of involves another 30 libraries that it depends on, and that's sort of a major complication. I think it's not as complex as ImageMagick, but comes close to it. So yeah, so and Nicolas replied, that's true for a lot of OSGeo users. They use QuantumGIS and PostGIS and have no clue that this all sort of is built on GDAL, GEOS, Proj, triple of the sort of the core libraries that everyone uses. So there's now an increase, since this has become relatively simple. There is now suddenly 10 or 15 R packages that all link to whatever, to GEOS or to GDAL and so on. So and that also poses problems, because everyone copies the scripts from SF but doesn't update them if I update them, because it's all copied and so on. So it's also difficult, right? And then they run into troubles, and then Ryan Ripley writes to me and so on, and these kind of things. So there's a lot of communication going on behind the scenes, yeah, and
Can I ask something about the RS classes? I see that a couple of packages took it as the standard.
The what classes?
RS. The RS was called the MLR3 now runs on the RS system.
R6.
R6, sorry.
R6.
R6.
Those are not classes. This is a framework for object orientation.
Mm-hmm. Can you say something about that?
No, it is mutable objects. So you use it. It's in particular useful if you have things like connections to web services or something like that, where you don't want to have sort of passing objects with copies, but passing them by reference, basically like environments. It works. It has use cases where you really benefit from it.
It's a total object-based programming, right? It's
yeah, but everything is. S3 is, S4 is.
Oh, yeah.
And this is R6 is a very lightweight. Basically, it's like reference classes in S4, but then in S3 and lightweight.
So can I ask, go back to the previous topic, because you were talking about connecting that many packages connects to Geos and Goodall and so on. Would it be possible to have a package which is actually a header with just a header package with Geos and Proj and Goodall, and then that would be the only package that would need to update its settings, and next the rest packages could just use the header library, as we use, for example, RCPP and RCP Armadillo and CP11 and so on?
You could, if I may try and answer. So this works for the boost headers, for instance. Yeah, the RCPP boost, because that's a header-only library. But GDAL and GEOS and Proj are not written as templates, as header libraries, right? So the headers is not enough for linking.
Yeah, but that's my point, that there would be a package that would be just like a storage for actual Proj and Goodall and so on, and the rest packages could use this package as a header.
Well, I mean, this is the way how our GDAL worked, right? And then one of the reasons why Robert started with Terra is that we was not happy with that. Is that right, Robert?
Well, not quite, because I could only access RGL through R, not directly through.
Exactly, but that is the only thing you have.
And so I think the answer to Jacob is that it's possible, and of course that's what happens on Linux, right? Because they only install GDAL once and then you compile the package against it. On Windows, it will be possible to be, but I think it's just against current policies to compile against sort of a DLL in another package. I'm not sure how complex it. I mean, apart from I think there's also complexity. I'm not sure how easy it will be to implement that on Windows. I really don't know, but I think it's also against the policy. So it would be those two. Maybe answer knows that better.
I think you can use a C interface with a linking to relationship, like who does that? Our Goodall does linking to SP for certain things. Yeah, but that is only a C interface, and you cannot do it for a C++ interface because of the name mangling. So that's not. I think we asked Jeroen at some stage. It's not possible. Thanks. So I don't think that R allows that. Yeah, the package system. Right, we are almost through our time. There is one final question I had, sort of difficult one. What are the major weaknesses and risks on the RSpatial ecosystem? So I thought of risks, the bus number and so on, those kind of things.
Yeah, so maybe
people retire is another risk. Yeah.
Yeah, I think there is one very important risk that if you look at the panel even right now with some major developers like you, Edzer, like Robert, like Martin, all of you are single major developers, and the second person is probably like a 100% of the commits or the content of the packages. So and I think it's very similar to most open source scientific software, let's say, that this is basically like a giant, but on the one leg giant, and that's, I think that's I don't know if it's even solvable, but that's definitely a problem that often a lot of things depends on one person, and it's also hard to engage other people. So I think that's another problem, how to engage other people to start from maybe reporting bugs, but move them in some point to start making pull requests and start getting them involved to making changes in the packages. And I can only share my own experience that that's what I do. I started from opening an issue, and now I try more often to make pull requests. And I've done that to stars, and done that to team up. And I learned a lot from that. So I think that could be also maybe a starting point, that I learned tons by reading other people's code and trying to implement some new changes or maybe fix some bugs. But that's what we need to do. We need to encourage people to do so. We need to find a way how to not split to make 20 different packages. 2 different packages is enough to solve the same problem, but how to move people to help each other and improve on existing and new software and collaborate on new software as well.
Yeah,
I think it also relates to the R community in general. I mean, see it in my employer, so Statistics Netherlands. There are many people use R, many people use Python, but most people who use R come from a statistics background and they don't have a clue about programming guidelines. So for instance, keep functions short, keep them to do one job, keep them well documented, etc., etc. So I've read so many scripts, and even myself. So when I look at some TMAP code, I say, well, what do I have done? So my aim for TMAP4 is in the end to keep short and well documented functions such that people like Jacob can really be main developers, and hopefully many others.
yeah. No, that's an excellent point. So both from writing for basically that other people can read it too, and not just that it runs, but it's also understandable. That's an important aspect. But excellent comment, Jacob. I mean, we need people, you know, like you and like everyone in the summer school, essentially, to get engaged, and you typically get very sort of friendly reactions if you're inexperienced and so on. If you contribute and try to sort of understand things and share questions and share code and try to improve things and come with suggestions like, why don't we do this like this or do it like that, and look at code, read a lot of code, right? If you want to learn, you start with reading, right? And we also see young people, much younger than Robert and me, doing actually very wild and creative developments, right? I was thinking of Dewey Dunnington, who essentially wrote S2 and comes with all these WK packages and stuff just to experiment, right? And come with different possibilities, and that is really helpful, and we need your involvement, and there's a lot of room, actually, a lot of room.
Ezra will have to stop. We are in overtime.